Today we're going to be learning about trapezoids and kites. Theorem 615 states that the base angles of an isosceles trapezoid are congruent. So if we take a look here, remember an isosceles trapezoid means we have one pair of parallel sides and the other sides are congruent to each other. So if I have an isosceles trapezoid, the base angles, which I write here, are congruent to each other. Theorem 616 states the diagonals of an isosceles trapezoid are also congruent. So if we label this A, B, C, D, then that means my diagonal, which is from A to C, is going to be congruent to my diagonal, which is from B to D. So AC is congruent to BD. So for example 1, trapezoid ABCD is an isosceles trapezoid. So that means AB is parallel to CD, and that also means AC is congruent to BD. It says we have our bases and that the measure of angle C is 67 degrees. We want to find all the other angle measures. Well, according to Theorem 615, the base angles of an isosceles trapezoid are congruent. So that means angle C is going to be congruent to angle D. So the measure of angle D will equal 67 degrees as well. But we also have to find the measure of angle A and the measure of angle B. If we take a look again, if these are our parallel sides, this is my transversal that cuts that. So that means to find the measure of angle A, 67 has to add together to this missing angle to be 180 degrees. So if I do 180 minus 67, we're left with 113. So that means the measure of angle A is 113 degrees. And that means also, since angle D is 67 degrees, these two also have to add together to be 180. So that means the measure of angle B is also 113 degrees. So example 2. TRAP is an isosceles trapezoid. TA, so the diagonal from T to A, is 5x plus 18. And then RP, which is my other diagonal, right here, that is 2x plus 30. We want to find x and the length of TA. Well, since I know this is an isosceles trapezoid, it tells me in Theorem 616 the isosceles trapezoid, the diagonals are congruent. If I'm looking at the diagonal TA and the diagonal RP, they are congruent. So that means 5x plus 18 equals 2x plus 30. So if we go to solve this to find x, we're going to subtract 2x to both sides. So 3x plus 18 equals 30. We then are going to subtract 18 to both sides. So 3x equals 12 divided by 3. X equals 4. But it also asks us to find the length of TA. So if I look at TA is 5x plus 18, but if I know my x is 4, if I did 5 times 4 plus 18, that means the length of TA is going to be 38. 5 times 4 is 20, plus 18, 38. So example 3. Isosceles trapezoid ABCD. So since it's not drawn out, I'm going to draw it out to the best of my ability. So A, B, C, D. It's an isosceles trapezoid, so that means AB is parallel to DC, and that also means AD is also congruent to BC. It says legs AB and CD are the bases, which is what we're showing, and the legs are, gotta label that better. The legs are A, B, and C, D. And the base is BC. if AB is 5y minus 10, and the BC is 6y plus 2, and CD is 2y plus 8. I want to find the value of y. So I'm looking at my picture. These two I know are congruent to each other. This one is not congruent to any of them. So actually this is more of a distractor, so we're not going to use 6y plus 2. But I do know that 5y minus 10 is going to equal 2y plus 8. So if I subtract 2y to both sides, 3y minus 10 equals 8. Add 10 to both sides, 3y equals 18. Divide by 3, y equals 6. And that is all we needed to find. So if we look at theorem 617, it says the diagonals of a kite are perpendicular. So if I draw in both of my diagonals into my kite, where they intersect, those four angles become 90 degrees. Remember, perpendicular means 90 degrees. Other properties of a kite. One pair of opposite angles are congruent. So in this, there's only one set of angles that are congruent, and those would be these two. So this angle and this angle are congruent. Ignoring the fact that the diagonal is cutting them, it's not bisecting them. It's just telling us that these two angles are congruent. So if this is A, angle A is congruent to angle B. It also tells us that the diagonal, which intersects the adjacent congruent sides, bisects the angles. So in our kite, we know AC is congruent to CB, and AD is congruent to BD. So what this is telling us is this diagonal right here, CD, bisects angle C and angle D. So that means this angle is going to be congruent to this one. And these two angles are congruent to each other, but they're not congruent to angle C. So we want to find the angle measures in the kite. We want to find the measures of the numbered. So we want to find angle 1, angle 2, and angle 3. So if we start with the measure of angle 1, angle 1 is over here. So according to our other properties of a kite, the diagonal that intersects the adjacent sides, so these two sides are adjacent and they're congruent, that means these two angles right here are congruent to each other. So that means if this angle is 39 degrees, angle 1 is also 39 degrees. So then the measure of angle 2. Our two angles are intersecting, and they intersect at a perpendicular. So that means angle 2 is 90 degrees. So then lastly, the measure of angle 3 is something we have to identify. So if we take a look right here, we end up with this little triangle based off of our two diagonals. So in this triangle, this angle is 90 degrees because remember they intersect and they become perpendicular. This one's 39, and we are trying to find the measure of angle 3. We know that in a triangle, three angles add together to be 180. So if I take what I don't know plus my 39 degrees and my 90 degrees, they will equal 180. So 39 plus 90 is 129. And if we subtract 129, we get that x is 51. So that really means that the measure of angle 3 is 51 degrees. So example 5. Measure of angle IKS. IKS right here is 34 degrees. And the measure of angle ETK, so down here is 24 degrees. We want to find the measure of angle EIK, so I want to find this angle right here. Measure of angle ESK, so this one right here. Let's mark it with an open circle. and the measure of angle ETI. ETI, so I want this angle down here. We're gonna say angle T. So 3 angles that we're trying to identify. Well, I already know right off the bat that the measure of angle ESK, because my diagonals are perpendicular to each other, so that means this angle right here has to be 90 degrees. So the measure of angle ESK is 90 degrees. Since I know that's 90 degrees, I also know this angle is 90 degrees. So once again, we are dealing with our triangle. So I have the fact that I have a 90-degree angle, so 90 plus 34, plus my missing angle has to add up to be 180. 90 plus 34 is 124. So when I subtract 124 from 180, I have that missing angle is going to be 56 degrees. So the measure of angle EIK is 56 degrees. So then lastly, we are dealing down here at angle T. Well, if I take a look, this diagonal is bisecting my angle, and I know that because these two angles are my adjacent congruent sides because of my kite. These two are also congruent. So that means that this is 24. This side also has to be 24 degrees because it's being bisected. So the measure of angle ETI is 24 degrees. Let's just take a look at what else we can find out. If that's 24 degrees, and that one's 24, I also know that this angle, angle K, is bisected by this diagonal. So that means this angle is also 34. If I have a 34, 90, 56, that means this angle is also 56 degrees. So then to find this third angle, it's not 56 because remember these two angles are congruent, but they're not bisected. So that means this angle, angle TIS, is not congruent to angle TES. So to find this angle right here, what we would do is we would do 24 plus 90, and we subtract by 180. And whatever angle we got for there, we would also get on that side as well, because they're not bisected, but they are equal to each other.